So we're trying to determine a relationship, and if we're looking at this first star field with how those are all scattered about, do you really see any relationship between, let's say, information on this axis and information on this axis here? Not really, right? Because they're all kind of scattered about. There's a little cluster in the middle, but that doesn't really show us anything. But what about for B? What can we say here about the pattern of those stars? And I did add a couple, so just think that they're all natural. Sabrina? Yeah, they're diagonal. They're going up. As this one goes up, then what is this one also doing? It's going up, right? So it has this positive relationship that we'll call it. So this is a positive. This had really no relationship in terms of how this one was being affected by this one. And then in this last one, think of always in an X and Y axis. What can we say about this relationship here? Andrew, let's just give everyone a chance. Carissa? Yeah, so as this one increases, this one's actually decreasing, right? So this is a negative relationship. Now, you can actually do this the opposite way. As this one goes up, what is this one doing? You can think of this as going down, going backwards. So, it's obviously we usually read it left to right, so we're seeing this going down or negative. That's fine, but just understand it works two ways. If one goes up, the other goes down. If that one goes up, then the other one goes down. So a negative relationship. So no relationship, positive and negative. With scatter plots, with these star fields, we could call them, will be what we're talking about today. All right. So we're going to start with graphs. So we're going to start with just looking at charts and tables, that is, and eventually we'll kind of talk about their graphs and how they look like on a Y and X axis. But these are all positive correlations, so we're going to stick with positive. So that means as one goes up, the other goes up as well. And we want to talk about their correlation coefficient. And man, is that a mouthful, right? But basically all that means is how does one variable affect another, and how close of a relationship is there, So we'll talk about some different situations, and we are talking about linear best fit, all right? So back to those straight lines, like we said last time. With these four tables, there is some good news. We are going to have to put them all in our calculator, but the X values for all of these are the same. 2, 5, 8, 11, 15, 18, 2, 5, 8, 11, 15, 18, 2, 5, 8, 11, 15, 18, and 2, 5, 8, 11, 15, 18. So that's good news that we won't have to keep changing that one. So calculator time, and am I still recording? Yes, we are. All right, let's go ahead. I'm going to start with a blank screen. Let me clear out whatever is on that screen. You shall maybe want to do that too. And again, if you don't have a graphing calculator, that's okay. You might want to write down the steps to doing this, but you won't need it for your practice assignment. You will need the information that we gain from the calculator, though, which will be provided. So stat key, remember when I hit it, it turns red, so that's how you can follow along. You want to edit the list. So like we did last time, press enter, and we're going to put these lists into our calculator. Now the first list, the list for the x-axis, not going to change for any one of these first four. So it's 2, and press enter. And it's 5, press enter. 8, enter. 11, enter. 15, 18. Now I needed something in order to show you this. So if you had something in your list and you needed to get rid of it, just come up to the top where it says L1, press clear. Don't do that now, but if there was something already there, press clear, and then when you move down, it'll all go away and you can enter that list. Did anybody have anything in their list? Any space junk there that needed to be cleared out? Should I wait for a second for that to happen? Entered. Now let's enter the Y values for this first one, which head over to list 2, L2, and it's going to be 4, 13, 22, 29, 43, and 52. Okay. Just double check to make sure all the numbers are correct. And I think we're good. All right. Same thing we did last class. So this is a great review. If you were home or weren't in person for our last meeting, press the stat key again. You got to go over to calculate. Okay. So over to calculate, and we're going to use the exact same button. We're going to use number 4, the same one that gave us the slope and the y-intercept from last time. So scroll down to 4 or just hit 4, press enter. And depending on how new your calculator is, it might have just a screen like this, or it might have a screen where it says L1, L2, I think something save or something like that, if you can help me out there, and then calculate. So you want to go all the way down to where it says calculate so that you can press enter, and voila, you get the slope and y-intercept. Now this is great that my calculator did this because it's not set up, it's not currently functioning how it should. So if you don't see an R here, all right, this is what you're going to need to do. How many people did not see an R? Okay, good. Did you see like an R value, R squared R, R squared R? No, it's like right down here below it. So we hit second 0. Second 0 brings up the catalog. We scrolled all the way down till we found diagnostic on, and that's going to give us the information that we need to use for class today. So press enter again, and then you should see a screen that says done. The action has been completed, and we're ready to go. So we got to repeat that process again. So stat key, and then we want to go over to calculate. We're choosing the option of number 4. And we're going to press enter. And ta-da! I see a little bit more information than I did last time. Did everybody get that? All right. But the new value that we're talking about today is the R value, not the R squared value, but the R value, the 0.998. We want to take this out to the nearest thousandth. So R value is equal to 0.998. I know that we usually round that, but I'm just going to keep it 0.998 so that you can see that relationship. And the reason is, all right, why this is so strong, why this is so close to 1, is because this is a change of 9. This is a change of 9. This is a change of 7. This is a change of 14. This is a change of 9. So these values have almost the same change because obviously this is going by 3s. These values are going up by almost the same amount every single time. And this isn't intended to be a line. This is a scatter plot. Let me kind of go back to what we had for our first image. These dots do not line perfectly up. They're kind of scattered, but these ones seem to be tighter together. Those stars are much, much closer. Okay? We're going to go a little faster, but how's the intro? How's the setup? We change the y values. The y values only, like I said, the x values for all of these will stay the same. So we have to go to the stat key. We got to edit a list. We're going to keep list 1, but we're going to clear list 2. So to clear list 2, we want to press the clear button when we're up at L2. Now it's going to look like nothing happened, but when you scroll down, now all of those numbers have disappeared. Okay? So I cleared out the y values, entered the new y values, and let's see the calculator do its thing. We want to go over from edit to calc, go down to number 4, and we're going to do the linear regression. Number 4, press enter, and voila, slope, y-intercept, and how good of a representation of the line is the data? 0.93. So that's actually a little bit further away from 1. I don't know. I know that it's not that much further. The other one was 0.998, but 0.93 is a little bit further away. So those values are going to be a little bit more spread out. So let's go ahead, write the equation. The equation is 2, 3, so 2 and 3/10 x, and plus 7.5 for a y-intercept, with a r value, a correlation coefficient of 0.930, meaning how well that line represents the data. Remember our split here was 9, 9, 7, 14, 9, had 3 9s, a 7, and a 14. It showed a pretty good relationship. How about this one? 2. Then this one is 8. And this one is 19. and then this one is actually down 4, -4, -2, and then this one goes up to 14 again. And what are we used to seeing with linear equations when we do this? We're used to seeing these numbers be exactly the same, and these numbers are clearly not, because once again, let me bring back what we started talking about, not Star Wars, but the fact that these are not a straight line. These are kind of up and down, kind of all over the place, and that is showing you how good of a fit the line of best fit is. All right, so how close to the line are those points really is what this R value is telling us. And the closer to 1 that it is, the closer the relationship, and we'll see a couple here in a moment that are further away from 1. All right. Later, we got another one to take a look at. I'll go much faster with this one because we've been through the process a couple times now. We need to edit the list. From here, we need to clear out that Y value list, the second list. So go up to where it says L2. When it's highlighted, press clear, and then jump back down. And it's going to be an 18 with an 8, with a 41, with a 28, with a 62, and a 44. And can somebody just kind of tell me? I've entered the new list from table C for the Y values, and we can see that the spread is pretty kind of crazy and chaotic. So what's that going to mean? We go stat button, over 1, down to number 4, and we press enter. And it gives us the slope, it gives us the y-intercept, and you can see our R value is creeping down to 0.7, meaning the relationship between this is actually quite low. So we go to the notes, we jot all this stuff down. Y equals 2.5x plus 8.9. There's our slope, our y-intercept. That can always be helpful, but our R value is 776. We like to take that to 3 decimal points. Okay. Last one that we'll do with the table in this first question. So, have been entered for our new list. Stat button, calculate the linear regression number 4. So down to number 4. Move on down to calculate if you need to. We get our slope, we get our y-intercept, we get our relationship between the y and x values, which is now down to 0.13. So take the time to write all that down. Slope 0.19x plus 43.5 for y-intercept. But the new thing that we're talking about today, 133 for a relationship. Yes. Yeah, you could round that to 0.2. 2/10 would be fine. Let me get rid of this weird looking X though. All right, and the fact that this is 0.133 means that the relationship between these is not very strong. We went up 7, then down 21, then up 25, then down 10, and up 2. There really was no pattern to that. Okay, so which correlation coefficient had the strongest relationship between the variables? So we got another table to look at, and you're welcome. I kept the x values the same. I didn't want to have to keep putting in new x values every time. But 52, 47, 28, 32, 25, 10. What do we see a consistency of? They're going down, all right? So let's see how that affects our R value. R would have been a good pirate day today, wouldn't it? So edit the list. So values have been entered. We've noticed that the pattern is that they're decreasing. We go over to calculate. We go down to number 4, and we press enter. We get our slope. Voila, it's negative. We saw that coming. Y-intercept of 55, and an R value, don't look over this, is a negative 0.9949. Okay, so let's get that down. There we go. Y equals negative, not 2.4, let's call it, x plus a 55.9 with an R value at -0.94, call it 5 when we round. And that actually represents a strong relationship. Strong because it's really, really close to -1.